Hello everyone, I'm Stuart McConaughey, and in this video I'm going to show you how to program the second operation in the TITAN-FIX-404, part of our fixturing series. First things first, I just imported my model. Going to move it all around. I have my Mighty Bytes modeled in. I'm in the design tab right now, so that way I can go to my model tree and go ahead and hide all of my Mighty Bytes and screws. It makes it a lot easier for programming. So once I have all of that hidden, now I can switch over to manufacturing. I'm going to make sure that my unit is set to inch. You can also hide over in the manufacturing tab as well. You can just simply unselect stuff. Once you have all of that done and hidden, we can do our setup for our cam. So I'm going to go up to setup, click setup, go to operation type, which is going to be mill. My orientation is going to be in Z and X. First thing is I select my Z or any Z surface, and then X, I select any horizontal line. I can click the arrow to flip it. So make sure that it is facing for Y of the back of the part and X for the right side of the part. Once I have that, then I go to my origin and I select model box point. Then I can click the far left back point, which is going to be this guy. There we go. All right, once you have that, then you can move on to the next tab, which is going to be our stock, where we define the size of our material. My material is 9.1. So type in 9.1. This is what we're going to cut it to. Once I have that, then I can move on to my width, which is 4 inch. My height is going to be 1.75, and I am going to make it not centered. I'm going to select offset from Z bottom, and the offset is just going to be 20 thousandths. This is how much we're going to take off from op A. So I have all this material down for op B. Once I have that, then I can move on to post-process, where I will give it a name of 1004 and comment it in as Titan-404 op 2. 0 for my machine work coordinate. We'll post a G54 for my offset. If you do a 1, it will also post a G54. So I try to just put in 1, make it a default. Now I can move on to our tool paths. First thing we're going to do is face it. So I'm going to go up to my 2D selection, click face, go to my tools, and in here I'm going to go to the local library and fixturing series and select my 3-inch face mill. Once I have that, then I can go in, make sure that flood coolant is turned on. My spindle is set to 10,000. My cutting feed rate is set to 100 inches per minute. Linear, lead out, and ramp and plunge are all going to be set to 100. I'm running this part on a VF6 SS. It's a pretty strong machine, but all of these speeds and feeds will be conservative. If you have a weaker machine, adjust your speeds and feeds accordingly. So once this is all set, then I can move on to the geometry tab. And in here, I have my stock contours where it can identify the stock material. I will leave that on. Once I have that, then I can move on to the next tab, which is just going to be my heights tab. And here I have my clearance height, which I will leave at 0.4 from my retract height. The retract height will be the stock top at 0.2 away. My feed height will be from the top of 0.2. The top of what we're going to be working with is the top of stock, and the bottom is going to be the top of the model. So all of this is correct. Now I can move on to the passes tab. And in here, I'm going to change my pass direction to 180 degrees. That way my shell mill starts by my work coordinate. My pass extension is going to be 1.6. So half the tool diameter plus 100 thou. The stock offset I will leave at 0. My step over I'm going to change to 2.2. The next thing we need to change is multiple depths. And in here, I'm going to put in 50 thou just to be conservative. I will add a finishing step of 5 thousandths and make step downs even and put in a finishing feed rate of 50 inches per minute. Nice and slow. Once I have this all set, then I can move on to my linking tab. And here I'm going to allow rapid retract, keep tool down. The maximum stay down I can leave at 15. Next is my leads and transitions. This is just going to be set to 0 for my vertical lead in radius since I'm plunging outside of the stock. Next is my transition type. This can just be a straight line. Doesn't need to be fancy. Once I have this, then I can click OK. And there we go. Our first pass goes in, bunch of cuts, does a nice little finish. Cool, looks good. Now that we have our face cut, now all we need to do is go ahead and start roughing out these channels and these pockets. To do that, I'm going to go up to 3D adaptive clearing. Next, I can go ahead and select my 1/2 inch end mill. To do that, I'm going to go to my local library, my fixturing series, and then click T2, which is our 1/2 inch end mill. Once I have that, I'm going to make sure that my speeds and feeds are set to 8,000 RPM at 75 inches per minute. My plunge is going to be 100 inches per minute. Once I have this all set, then I can move on to the next tab, which is going to be my geometry tab. And here I'm going to make sure that my machining boundary is set to none. My stock contours though, since the first operation finished the outside of the part, I need to change the stock contours to the profile of my part. To do that, simply go down to this bottom edge, click it, and it should select this whole thing. We do need to adjust our chain because we do not want this and we want it to go up and around this cutout. So to do that, simply click the yellow line. Once you have that, the black line is the suggested path and the blue line is what you've clicked. So next we can just click this top edge or all the lines around it until we get the correct profile. Now you have to be careful and make sure that you click the outside of the part, which would be the outside of this chamfer. And once we have it done on one side, then we can simply move our part around until we get to this other side and repeat the process. Up, over, should be all good. Make sure the black line's on the outside and click OK. So now I have the stock chained around it, just around the outside. That's perfect. Once I have that done, then I can go ahead and go to the next tab, which is rest machining. And here we're going to just turn this off. After that, we can go to our heights tab. And here we have our first height, which is going to be model top since we've already faced it. The retract height is model top. My top height will also be model top. The bottom height will just be the bottom of the lowest feature that I need cut. So I could do selection, grab the floor, and then I could go -30 just to get my tool right under it. And then next thing is we could change this to 0.1 and the clearance to 0.1 since everything's all cut away. The top height we actually need to change to -10. And this is so that way our 3D adaptive path can properly work and it won't cut the top, which has already been faced. So once I have this, then I can move on to the passes tab. And here we're simply going to go in and change this to 0.1 or 100 thousandths for our optimum load. Next is our minimum cutting radius. We're going to put in 25 thousandths, and I will have machine cavities turned on so that way I can do this pocket. Then we can move on to our maximum roughing step down, and we are going to make sure that this is set to 1 inch with a fine step down of 0.1. Next, we're going to turn on flat area detection and change that to 10 thousandths or 0.01. Once we have that set, then we can go ahead and turn on our stock to leave and give it a radial value of 10 thou and an axial value of 10 thou. Once we have that, then we can move on to our linking tab. And here we're going to make sure that everything is set. 4 inches, 0.1. Stay down level is going to be 70%. The no feed rate engagement will be 500. Next is leads and transitions. We will leave this at 50 thou. After that, we have our ramp. Here we're going to set it to helix with a 2-degree ramp angle and a helical diameter of 0.475. Once we have all of this set, then we can click OK. And there we go. That is the tool path. Now I'm just going to turn off this grid, just to make it a little easier for you guys. And then I am going to change the orientation of everything. To do that, you just right click, change this to top, just to make things nice and symmetric. I can quickly click all these different points and see all my heights. See this nice little 10 thou, it's perfect. Okay, so that is the roughing. That is all done now. So now that we have our part roughed, now we can go ahead and start finishing. We are going to finish the floors of these 3 first, and then we will come back in and finish the sides. Now, to do that, first we will go to our 3D toolpath and we will go to horizontal. Once we have horizontal pulled up, we will go ahead and change our speeds and feeds, since we're now finishing, to 5,000 RPM at 40 inches per minute. Once we have that set, then we can move on to geometry. And here we're just going to make sure that the machining boundary is set to none. Our height, we are going to change to 0.1, model top. We'll change model top, and this will also be 0.1. Next is top height. And we will actually give this a negative value, so that way our containment is under the top of the part. And then the next thing is the bottom height, which we can set to at least this floor or even 30 thou under that. Next, we can move on to our passes tab. And here we're going to go ahead and make sure that the minimum cutting radius is set to 0. Smoothing deviation we could set to 5 thousandths. Next is stock to leave, and here we are going to change the radial stock to leave to 10 thou, but the axial we will set to 0. This lets me finish the floor without finishing the walls. The walls I need to use cutter comp, and the 3D horizontal strategy does not have the ability to sense or comp in our distances. So we will just be using it to finish this floor and these other floors too. So once we have that, then we can go to the linking tab. And here we're going to change the safe distance to 0.1, the maximum stay down distance to 4 inches. Next is our horizontal leads and our vertical lead in radius. We can leave all this set to 50, so that way we have a nice entry into our pocket. And we will change the ramp to plunge with a clearance height of 0.1. Once we have that all set, then we can move on and click OK. Perfect. Everything looks good. So now that we have our floors nice and finished, we can now go through and start cutting these walls. To do that, we simply go up to 2D contour. Make sure that we have T2 selected, which is our 1/2" end mill. We're going to go through and make sure that the spindle is set to 5,000 at 40 inches a minute with a 100-inch a minute plunge. Once we have that all set, then we're going to go to the next tab, which is our geometry tab. And here we're going to make sure that we go in and select the contour of what we want to cut. When I do select it, I do need to go in and make sure that it selects the outside radius, the bottom line, and also this inside radius. Once I have that, then I can click OK, and I'll have my profile. Next, I can move on to the next side, which is going to be this leg. Same thing, I'll click it. I can see it selected this first fillet, but it did not select this one. So I will go in and modify the chain by simply clicking it again, and then going in and clicking the next fillet. Now that I have both of my fillets done, I can then go ahead and move on to the next tab. Here we're going to change the clearance height to model top and with a distance of 0.1. The retract height will also change to 0.1. My feed height will be also the model top and 0.1 above. The top height will just be the top of our part. The bottom height can be selection or selected contours. In this case, since I'm clicking the bottom of our path. Next, we can move on to the passes tab. And in here, I'm going to make sure and change the compensation type to wear. Once I have this all set, then I can go ahead and move on to the linking tab. Here, I'm going to change the safe distance to 0.1, and I will make sure to keep the tool down. My maximum stay down distance, I will leave at 2 inches, so that way it can swiftly go over. Next, we're in leads and transitions, and here I'm going to take away the vertical lead in radius. Later on, I will add it for this pocket, so that way we have a nice entry, but on these outside channels, it is not necessary, since I'm plunging outside of the material. Once I have that, then I can click OK. Now we can go ahead and do the next floor, which is going to be this guy, since we just did this one. To make it easy, and we can just right click and duplicate the path that we just made and simply go to our geometry tab and simply reselect the new geometry that we need. Once I click the edge bottom of the pocket I want cut, I'm going to make sure that it actually selects the whole thing. So I will click and modify the blue line and add another. Now that I have the full profile, I can go to the next side, click this. I can see that we have the fillet, we have everything, but we don't have this. So I will simply click it again and zoom in and click this guy. So you can see it automatically tries to go all the way around. So we have to now go ahead and click all of the lines that we want. So as I move forward, this upper chain starts going away. I ended up having to click every line for it to finally recognize that it is a partial, but that's what you need to do. Now that I have that done, I can click OK, green check, and now we have our two profiles. All of our settings should be perfect since the bottom height is selected contours and we clicked the bottom contour. That should be correct. Everything else should be correct, just double checking. And we should click OK. And there we go. So next we just need to do this pocket. Same thing, I will just right click and duplicate. And in here, we are going to repeat the process and reselect the chain that we want cut. The height, I can just make sure it's set to selected contours. My passes tab will be the same. The leads and transitions, I will put back in the 50 thou just so I have a nice entry to the pocket, and that looks great. So now that we have all of our vertical walls finished, now all we need to do is go ahead and drill out our large holes for our mighty bites, which are going to be these guys. I will go up to drill, go to my tool and select my 12.5 millimeter go drill, which is going to be in the local library. And I have it set to 6,290 RPM at 50 inches a minute. This is a great speed and feed for my VF6. If you have a weaker machine, you can adjust this. Next, we can move on to geometry. And here I'm simply going to select the whole faces of what I need cut, which is going to be all 4 of these guys. Once I have that done, then I can move on to the heights tab. Here, I'm just going to make sure that everything is set to model top. So once I have all this, I will make sure to change the feed height to 0.1, my retract height to 0.1, my clearance height to 0.1. Next is the whole bottom. And in this, I'm going to make sure that drill tip through bottom is checked and that I give my drill an extra 50 thousandths below my part, just so that way it properly cleans up. Once I have this all set, then we should be good to move on to the next tab. If you have chips that wrap around your drill, normally you would increase the feed rate to get rid of that. But if you have a weak machine and you can't, you might be able to raise the clearance height to help promote those chips to come off the bottom of the drill. We don't need that, so we will just put in 0.1. So once you have all these set, then you can move on to the next tab, which is our cycle type tab. And here we're just going to make sure that it is set to drilling and wrap it out. Once you have that, then you click OK. Our hole is all completely drilled and we can start chamfering. And here we are going to break up our chamfering into 2 different passes. One pass is going to have chamfers already, the other will not for these lower lines. So we can go up to 2D and chamfer. Next we go ahead to our tool and we will go in and select our chamfer mill from our fixturing series local library, 1/4 inch chamfer. Once we have that set, I will change my speeds and feeds to 10,000 RPM at 100 inches per minute. Next is the geometry, and in here I will simply select everything that has been drilled or machined out that has a chamfer. The first thing will be this pocket, this island I should say. I will select the inside edge of the chamfer. Same thing with each of these holes and this large pocket. Next is going to be this island. And in here I will do the same thing, select this, go move on to the next island, select the inside of this and the outside of this, or the top line. Once I have this set, then I can move on to the heights tab. And here I'm going to make sure that everything is set to model top. Once I have this all set, I will change the feed height and retract and clearance to 0.1. Next, I can move on to the passes tab. Here I'm going to make sure that the compensation type is set to wear. My chamfer width, since it's already modeled in, I don't need to put in the chamfer. The chamfer tip offset, I will put in 0.1, so that way it can get properly to the edge of the business end of the chamfer, give us a nice clean cut. Next, we can move on to the linking tab. Here I'm going to make sure that the safe distance is 0.1 and that our linear lead-in distance is 25 thou. Once I have this all set, then I can click OK. And we now have our chamfers. So we go ahead and chamfer everything up here, but we still have these 4 lines down below. So we will go ahead and chamfer that now. To do that, I will simply right click and duplicate the path I just made. Simply go and edit. The speeds and feeds will be good. My contour selection I will get rid of and only select the lines that I need, which are just going to be these side profile lines. Once I have these set, then I can move on to my heights tab. Make sure this is set to selected contours. All of this should be the same since we duplicated it. Next, I can move on to the passes tab. And here I'm actually just going to tell it to make a 10 thousandths chamfer. Everything else is going to be the same except for this. Once I have this, then I can move on to the next tab, which is our linking tab. And here, all of these settings are perfect with a linear lead-in distance of 25 thou. And once I have this all set, then I will click OK. And there we go. Now these edges are chamfered and so are the top. So now that we have these lower edges chamfered, now we can go ahead and start chamfering our threads. The first thread that we are going to chamfer is going to be these 3, which are our 632 threads. To do that, we simply go to drill. We're going to make sure that T6, our 1/4 inch chamfer tool, is selected. I'm going to change the RPM to 6,000 inches a minute at a 20 inch a minute plunge. Once I have that, then I can go to the geometry tab and select each of the 3 holes that I need spot drilled. Next, I'm going to move on to the clearance height. Change this to model top. Retract height, change that to model top. The feed height and the top height I will leave at hole top, but the bottom height I will change to chamfer to diameter. Now, since the major is 146-ish on the high, the max tolerance of it is 146. The minimum is 138, so I'm going to give it a 10% chamfer diameter of the thread, which will give me about 160 for my diameter. Next, I'm just going to see if I can lower this little retract right here. And to do that, I will change the feed height to hole top and the retract height to hole top. So now it's much lower. Change this to 0.1. I could leave this to 0.1 as well. So it leads in, goes over, leads out. It's nice and low, nice and safe. Once I have this set, then I can move on to the next tab, which is our cycle type. And in here, I will make sure that this is set to drilling and click OK. Now, the reason why we use the 1/4 inch is so that way we can fit the tool next to each of these holes. These other holes, the 3/8 and so on, are larger and we need to use a bigger chamfer tool. So now we are going to chamfer these holes over here, which are going to be our 1032 threads. So we're going to go up to drill, and we have to change our tool to a larger chamfer mill since the thread is going to be just a little bit bigger. We can do the 1032 with the 1/4 inch chamfer mill, but it's easier to switch now so that way we can just go through and chamfer all of the stuff that we need to with that tool without a unnecessary tool change. So once we have our 1/2 inch chamfer mill, we're going to make sure the spindle speed is set to 6,000 RPM and the plunge feed rate is 20 inches per minute. Next, we're going to go and select both our holes. I'm going to click these two. Once we have that set, then we can move on to the heights tab. And here we're going to tell it a specific chamfer diameter. Since I have a major of 0.198, 0.19-ish, we're going to do 10% over the major diameter. So that way we have a full chamfer cleanup. The number we're going to put in is 0.2178, and this will give us a nice full chamfer. Once I have that, then I can go up to the next tab, which is going to be the top of our cycle, which is our whole top. Next is the feed height. Here we would do the whole top. The retract, we could also do whole top, so that way the retract is nice and low. The clearance height, we will do model top with a value of 0.1, so that way everything clears. Our feed height, we can also do whole top. So we can see that the cycle is nice and low. We can see the tool fits in between. Everything looks perfect. Once we have this, then we can move on to the cycle tab. And here we're just going to make sure that it's set to drilling and rapid out. Now, once we have this done and our 1032s are now chamfered, we could then move on to the next set of holes that we need to chamfer. And that we can go ahead and do these two top ones over here. To do that, we're going to simply right click and duplicate the path that we just created. Once we duplicated our path, our speeds and feeds are going to be the same at 6,000 RPM, 20 inches a minute. Next, we can move on to our geometry tab. And here we're simply going to select the inside of both of these bores, which will be used later on. Next, we can move on to our heights tab. Here, I'm going to make sure that the clearance height is set to model top and 0.1 above. The retract height, I will set to whole top, 0.1 above. Since this is model top, you could also set it as model top. The feed height will be 0.1 above the hole. Same thing with the top height, but we'll leave it as an offset of 0. Now the bottom height, since I have my chamfer modeled in, what I can do is I could simply go to bottom height to chamfer width and give it a value of 0. This will make sure that the tool meets the edge of this hole, which will also give us a perfect chamfer. So once we have that, then we could go ahead and go to the next tab, which is going to be our cycle tab. And here we're going to make sure that it is set to drill. Okay, now that we have these two holes chamfered, next we will move on to our 1/4 20 hole. Now, all we need to do is go ahead and chamfer this. So we're going to right click and duplicate the path that we just created. We are then going to make sure that the spindle speed is set to 6,000 RPM with a plunge of 20 inches per minute. Once we have this, then we can move on to the geometry tab, where we are going to reselect and delete the old geometry and select the new geometry, which is going to be this 1/4 20 hole. Once we have that hole selected, then we can move on to the next tab, where we are going to change the bottom height to a specific chamfer diameter. Since it's a 1/4 20 thread with a major of 250, 250-ish. I can times it by 1.1 and get a new value of 10% over the major, which will give me a complete nice chamfer. Now after that, we are going to type in our new chamfer diameter, which is going to be our depth for our path, or our path is going to go to the right depth to get us the chamfer of 275. Once we have that, then we can move on to the next tab, which is going to be our cycle tab. And here we're just going to make sure that the cycle type is set to drilling and wrap it out. Once we have that, then we can click OK. And there we go. Now that we have our 1/4-20 thread chamfered, we can then move on to the next hole that we need to chamfer, which is going to be our 2 3/8 16 threads. So all we're going to do is right click and duplicate the path that we just made. And we're going to right click edit and make sure we go to our tool tab. And here we're just going to double check that it is the 1/2 inch spot drill at 6,000 RPM, 20 inches per minute. Next, we're going to delete the old geometry and reselect our new geometry, which is going to be these 2 holes right here, which are going to be our 3/8 16 threads. Once we have that, then we can move on to the next tab, which is going to be our heights tab. And here we can make sure that the clearance height is set to model top. Our retract height is set to hole top. Same thing with the feed and the top height. Now the bottom height, we are going to change the chamfer diameter that it is set to a new number, which is going to be 0.4125. And this will give us the correct chamfer diameter for a 3/8 16 thread, which is just 10% of the major added on. Once I have that, I'm going to make sure that the retract is above my part. Then we're going to move on to the cycle tab and make sure it's set to drilling wrap it out. Perfect. Now that we have all of our holes chamfered, we can now start drilling. The first thing we are going to do is drill and tap the 1032 threads. To do that, we can start by going up to our cam path, where we can go through and select drilling. We then need to go and change our tool from the 1/2 inch spot drill to our number 16 drill, which is going to be in our local library fixturing series. And this is a diameter of 0.177. This is the correct drill for a roll tap, which we will use to make these threads. Now that I have my number 16 drill selected, I'm going to make sure that the spindle speed is set to 8,600 RPM with a plunge feed rate of 38 inches per minute, 39. Once you have this set, you can then move on to the geometry tab, where we're going to select the whole face of the 2 holes that we want drilled. Once I have that selected, then I can move on to the heights tab. And here, first thing we will change is the clearance height. We will say that it is going to be selected off model top, and that the retract height is actually going to be selected off the hole top. Same thing with the feed height and top height. Now both of these numbers I will change to 0.1. Once I have these selected, I will then go down to bottom height and make sure it is set to hole bottom. Next, I will go ahead and click drill tip through bottom, which lowers my path to use the whole length of the hole. Once I have this, then I can move on to the cycle tab and make sure it is set to drilling. Once I have that, then I can click OK. So now that we've drilled out our 1032 holes, we can actually use that same drill to rough out our 250 counterbores. So to do that, we're simply going to right click and duplicate the path that we just made, and we will go and edit and recheck that our speeds and feeds are correct for drilling out these two holes. I'm going to make sure that my spindle speed is set to 8,600 RPM at 39 inches per minute. Next, I'm going to delete the old hole selections and go ahead and select both of these counterbores. Next, I'm going to go to the heights tab, where I will change my bottom height to hole bottom without drill through bottom, but I will put in a negative value of 0.026-ish. And this is actually so that way the carbide go drill can actually chamfer my 540 threads that will be in the bottom of this 250 counterbore. Once I have that done, I can then move on to the next tab, which is going to be the cycle tab, and I will make sure that the cycle type is set to drill rapid out, and click OK. So we have our 1032s, which are getting drilled out by our 0.177 drill, and since we have that tool already up and already machining, we will use that same tool to rough out the hole for our 250 counterbores. The depth of it we will also use to spot and chamfer the 540 threads that are in the bottom of these counterbores. Next thing we're going to do is tap the 1032 threads. To do that, we are going to go up to drill, click drill, and we are going to go to our tool tab, where we are going to select our 1032 roll tap. To do that, we are going to go to the local library fixturing series, and we will scroll down until we find tool number 16, which is our right hand 1032 roll tap. Once we have that tool selected, we can then move on to the geometry tab, where we need to select the holes that we are going to tap, which is going to be these two right here. Once I have that selected, I can then move on to the heights tab. Now the heights tab, we are going to change the clearance height to model top and put in a value of 0.1. The retract height we will change to hole top. The feed height we will also change to hole top, and we will change both of these offset numbers to 0.1. Keep our tool nice and down. Once we have that, then we can move on to the top height. Here we're going to make sure it's set to hole top with an offset of 0. The bottom height we are going to change to hole top and type in a negative value of 0.5. We have a minimum thread callout of 0.5. Our drill is going 0.6 down to the shoulder. So we are going to then add in the lead of our tap, which is the distance to the first full thread, which is going to be another 50 thousandths. Once we have this all set, then we can move on to the next tab, which is going to be our cycle tab. And here we're just going to make sure it's set to tapping. Once we have that, then we can click OK. Now that we have our 1032s, we can then move on. The next thing that we are going to do is rough out the 0.25 counterbores. And we could do that a couple different ways. The way that we're going to show you is by using a 1/8 end mill and coming in and helixing down and roughing out our material and finishing this inside diameter. We can go ahead and go up to 2D bore, and we can go click our tool tab and select our new tool, which is going to be in our local library fixturing series. We're going to click T4, which is our 1/8 end mill. Once I have that, I can then click OK. My spindle speed is going to be set at 10,000 RPM and 30 inches per minute. Lead in, feed rate, and lead out, ramp, and plunge will all be set to the same thing of 30 inches per minute. Once I have that, I can then move on and go to the geometry tab And here I'm going to simply go ahead and select the inside of each bore. It's going to be these two. Once I have this done, I can then move on to the heights tab. Once I'm here, I'm going to change the clearance height to model top with a value of 0.1. Next, I can change the retract height to model top with a value of 0.1. Next, we are going to go to the top height and change this to model top as well. The very last is going to be the bottom height. And here we are going to be very sure and select the bottom of the pocket itself. Whole top will also work. I prefer selection and physically selecting the surface that I know is the bottom, just so that way my path is always good. Once I have that, I can then move on to the passes tab. One thing that I do want to make sure is that the pitch or the ramp is set to 25 thou. It's a very safe number for this end mill. Once I have that, I'm then going to go to compensation type and change this to wear. Next, I'm going to go down to finishing passes. I'm just going to add a finishing pass at 5 thousandths just to get a nice perfect cleanup. And since it is a very small tool and I am worried about deflection, I will also repeat that pass. This will help get any deflection out of the bore. Once I have this all done, then I can move on to the next tab, which is going to be my linking tab. And in here, I'm going to make sure that the safe distance is set to 100 thou. Once I have this set to 100 thou, I can then also go down to leads and transitions and change lead to center and enable it. This helps move all my path to the center of my bore, making sure my tool doesn't hit anything and is nice and safe. Now, once I have this, I can then click OK. And as you can see, the 1/4 inch counter bore is now roughed out and finished. With everything all ready, we can then now move on to the next path. All right, now that we have our bore roughed, we can then move on to the next path, and that is going to be drilling out our 632 threads. So to do that, we are going to go up to drill, and we are then going to go ahead to our tool tab, and we are going to select a new tool. For our 632 threads, we're going to go to our local library fixturing series, and we're going to select a 1/8 inch drill, 0.125 in diameter. Okay, now that we have our 1/8 inch drill, which is the right drill for a 632 roll tap, we can then go ahead and make sure that our spindle speed is set to 9,000 RPM at 28 inches per minute, 9,170 at 28.7 inches per minute. Once we have that done, we can then go ahead and move on to the geometry tab. And here we are simply going to click these 3 holes right here, which are our 632 holes. Next, we can move on to the heights tab, which we are going to change the clearance height to model top with a offset of 0.1. Next, we can go ahead to our retract height and say whole top, and same thing with the feed height and change both of these to 0.1. Next, we can go ahead to the top height, and this we can set to whole top with a value of 0. The next section is going to be bottom height, and this we're going to make sure is set to whole bottom and that we check drill tip through bottom, which would lower the drill to give us a depth to the drill shoulder of -0.6. Once we have that, we can then move on to the cycle tab, and we're going to make sure that this cycle type is set to drilling rapid out. Once we have that, we're going to click OK. Now that we have our 632 threads drilled out, we can then tap them. And to do that, I'm just going to right click duplicate the path that we just made and go back to our local library, our tool tab, and change our drill to our 632 roll tap, which is going to be tool 19. Once I have that, I can then click OK, go to the geometry and make sure that both of these are all selected. Now I could reverse the order, save a little bit of time and have it start where it ended. Once we have this done, we can then move on to the heights tab, and here we will not select drill tip through bottom, and that we will make sure that it is going to be with a value of -0.55 from hole top. Since we have our drill, which is going -600 to the shoulder of the drill, we are going to send our tap in -0.55, which will give us our minimum thread of -0.5 minimum by going 50 thousandths past, which is the lead of our tap. So once we have this set, we can then move on to the next tab, which is going to be the cycle tab. And here we're going to make sure that the cycle type is set to tapping. Once I have this, I'm going to click OK, verify that everything is perfect, and we are good. So now the 632s are drilled and tapped. Our next feature, 3/8 16 threads. So first things first, we're going to drill it out since we've already spotted it or made our chamfers already. So to do that, I'm going to go up and click drill. Once that has popped up, I will then go and change my tool, go to my local library fixturing series. And here I'm going to select my S drill, which is the correct drill for a 3/8 16 roll tap. Once I have that selected, I will click OK. Here I'm just going to make sure that the RPM is set to 5,480 with a plunge feed rate of 38 inches per minute. Once I have this all set, I can then move on to the geometry tab, where we are going to select both of these holes. These holes are going to be the 3/8 16 threads. Once I have these holes selected, I can then move on to the heights tab. Here I'm going to change the clearance height to model top. Same thing as all the others, 0.1. My retract height, I will do hole top, 0.1. And the feed height, I will also do hole top and 0.1. So that way my drill is nice and low. Once I have this, then I can go to the top height, which will be hole top. My bottom height, I will say that it is the hole bottom, and I will make sure that drill tip goes through bottom. Since the hole does go completely through, it will clear. Next, I'm just going to give it a negative value of 50 thousandths, just so that way I know the drill will completely break through the bottom of the part. Once I have this done, I can then move on to the cycle tab, and I will make sure that it is set to drilling rapid out. Once I have this all done, I can then go ahead and click OK. So now the 3/8 16 threads are drilled out. Next, I can go ahead and tap them. To do that, I will simply right-click the path I just made and duplicate it. Next, I will go ahead and right-click Edit. Here, we will then go to the Tool tab and change our tool from our S drill to our 3/8 16 roll tap. That tool is in our local library. So we'll go ahead to T15 and click that. Now I have the 3/8 16 tap selected, the roll tap selected. I will make sure that the spindle speed is set to 500 RPM. Once I have that done, I can then move on to the geometry tab. And here we already have our two holes selected. So all I'm going to do is reverse the order to save some time. Once I have that done, I can then move on to the heights tab. Here, everything should be all correct except for through bottom. I don't really need that because the tap will automatically go through bottom since there's no point. When there is a drill tip point, you can toggle this, which would get it to go down the full distance. Since this doesn't have a point, it will not change it. So all these numbers are correct and the same, with the clearance height being 0.1 from the model, the retract height being whole top, feed height, whole top, top height is also the whole top. Once you have this all done, you can then move on to the cycle tab. Here we're going to make sure that the cycle type is set to tapping. Once we have that, we can then click OK. And there we go. All right, now we can move on to drilling and tapping our 1/4-20 thread. So first things first, we'll go and click drill. Next, we will go to our tool and we will select, and then we will go to our local library fixturing series. And here we're going to select T10, tool number 10, which is a number 1 go drill, carbide. Once we have this selected, we're going to make sure that the spindle speed is set to 8,300 and that the feed rate is 41 inches per minute. Plunge feed rate is set to 42 inches per minute. Once we have this, we can then go to the geometry tab where we will go ahead and select our 1/4-20 thread. Once I have this, I can then move on to the heights tab. And here I'm going to change the clearance height to model top with a offset of 0.1. My retract height I will change to whole top. The feed height I will also change to whole top. My retract height I will give it a value of 0.1. Same with the feed height. Next we have our top height. That's going to be the top of the hole or from whole top. Next is the bottom height. And here I'm going to make sure and click through bottom so that way the drill can go to the proper depth. Once I have this, I can then move on to the cycle tab. And here I'm going to make sure that the cycle type is set to drilling rapid out. Once I have this, then I can go ahead and click OK. Now that we have our 1/4-20 hole drilled out, we can then tap it. To do that, I will simply right click and duplicate the path I just made and right click edit. Then go to the tool tab and change the tool from the number 1 drill. Go to the local library fixturing series and grab the 1/4-20 roll tap, which is going to be tool 17. Once I have that, I can then go to the geometry and make sure that the hole is selected. Once I have that done, I can then move on to the heights tab and I will deselect drill hole through bottom and I will change the bottom height to whole top and give it a value of negative 0.750. I will change this to 775 and this will give me the correct minimum depth. I can then move on to the cycle tab and make sure that it is set to tapping. Once I have this all done, I can then go ahead and click OK. And there we have it. All right, so we're going to go up to drill and we are going to go to our tool tab and go into select a new tool, which is in our local library fixturing series. And in here, we're going to go ahead and select tool number 14, which is our number 33 drill. Go ahead and click OK. I'm going to double check, make sure that my speeds and feeds are correct. I'm going to set my plunge feed rate at 28 inches per minute with a spindle speed of 10,000 RPM. Once I have this set, I can then move on to the next tab, which is my geometry tab. And here I'm going to go ahead and click both of these holes, which are my 540 threads. Once I have these selected, I can move on to the heights tab where I change the clearance height to model top with a offset of 0.1. Next is my retract height. I will change this to hole top and give it a offset of 0.1. Next is the feed height, which I will also put in a value of 0.1 and change to hole top. I will not do that because it would crash. I will change this to model top. There we go. So once I have this set, then I can go down to the top height, and in this tab, I will leave this at 0 since I've already gone in and roughed it all out. Next, I can move on to bottom height, and here I will make sure it's set to hole bottom. Once this is set to hole bottom with a offset of 0, I will also check mark the drill tip through bottom, so that way the drill goes to the proper depth. Once I have this set, I can then move on to the cycle tab and make sure that it is set to drilling rapid out. Now that that is done, our drilling for our 540 threads is complete. Now all we need to do is tap it. And to do this, I can simply right click and duplicate the path that I just created. So same thing that applies. Go ahead and right click and duplicate. Here I can simply go ahead and edit the tool path, go to my tool tab, click tool, go to my local library fixturing series, and change the tool from the number 33 drill to my 540 roll tap, which is going to be T20. Once I have this selected, I can then go ahead to my geometry tab, and I will reverse the order so that way it enters on the hole that I left off. Next, I can move on to my heights tab. Here I will not select drill hole through bottom, and instead I will raise the path 25 thou, so that way my tap has some clearance against the drill bottom. Once I have this all done and everything is set to hole top, model top, the value of 0.1, hole top, a value of 0.1. I can then go ahead and double check that the clearance height is also set to hole top 0.1. Once I have this all set, then I can move on to the cycle tab and make sure that it is set to tapping. Once I have that, I can click OK. Now that we have these 540 threads done, the final and last thing that we need to do is come in and ream out our large 1/2-inch holes, which are going to be over 0.5. So that way our Mighty Bite ID expansion clamps can hold our fixture perfect. So to do that, we're going to go up to the drill tab, and we are going to make a new drill path. I will go to the tool tab and select a new tool in my local library fixturing series. Now we made the hole with the 12.5 millimeter go drill, and now all we need to do is ream it out with the 0.503 reamer. So I will go down to T22, select it. I will make sure that my spindle speed is set to 2,670 RPM with a plunge feed rate of 8 inches per minute. Once I have this all set, I can then move on to my geometry tab, and here I will simply go in and select all 4 holes. Once I have these holes all selected, I can move on to my heights tab. Here I'm going to make sure that the clearance height is set to model top. Go in and give it a value of 0.1. My retract height I will set to model top. Same thing with my feed and my top height. Once these are all set, I will go in and make sure that the offset for both the feed and the retract is 0.1. Next, I will go to the bottom height, and here I will go ahead and make sure that it goes to model bottom. The reamer that I am running has a 100 thou lead, so I will change this to -0.1. You can go ahead and measure your reamer and make sure that you have the correct lead depth for your hole, so that way the reamer completely goes all the way through the model bottom. It's always good to do this, double checking leads for taps, threads, drills. So once I have this all done, I can then move on to the cycle tab, and I will make sure that the cycle type is set to reaming and feed out. Once I have that, I will click OK. So now the holes are reamed. Threads should be all done. So now that I've simulated it and gone through and checked out everything, I will go up and save it. Click OK, and that is it. I'm Stuart McConaughey, and that's how you program the TITAN-FIX-404 Op 2.